So today I'm going to tell you a little bit about the progress we've made on the ion propulsion on the power supply. I already talked a little bit about it in the last video we made, but that was more of an overview, and today I will go a little bit more into the details. For the last year or so we've been making developments of a printed circuit board, PCBs, in approximately 10 by 10 centimeters, all in order to go into the cubesat, of which I have here a board which is, you can say, a mock-up board. It just has the right space, let's say the right size. It's made by Easy Space, who also delivers the cubesat kit. And those kind of boards like this one here, what we've been doing is we've been adding components to them. Here is just one component on in one of the examples. We then add several components and at the end we've been adding our high tension components on top in places like this, and getting them tested. Now this was the test we made before Christmas, and this was the test that didn't quite go the way we wanted, and where we ended up basically concluding that the board, which we have actually invested quite some time in getting to work, is not working and doesn't seem to be the right way to go. So we've gone back to basics, and I've told you a little bit about that earlier on. We're going to use our high tension components basically as they are, and that worked out very well in the last test in Vienna, the Pico. We've had contacts to the provider of these, and they have assured us that they will work also under the space conditions that we are expected to go into, at least for our first mission ROMIT 1. So therefore it becomes a question of now of getting them mounted on something which actually solves a problem we found last time, which is that they do get hot when we use them. And this is where we are doing now a set of heat balance calculations, and this component is guaranteed to work up to 100 centigrades. Which should work quite well for us. Our ion propulsion system will actually work at more like 200 degrees centigrade, and that means we will have issues of the heat balance inside our cubesat. However, for that, let's say, in order to mount them on something, it's therefore very important that we change from a PCB which does not conduct the heat to something which is aluminium. This little board with its attachments and so on is just a very rough sketch, you can call it, made in my basement, nothing special. But just today I had now something much closer to the real thing. Laser cut aluminium in 1.5 millimeters, and I have now 2-3 of them, and those will be the next where we will mount this components on, so that they get a heat surface where they can get rid of the excess heat, and that we can then look into our detailed heat balance calculations, and we can also actually test it and measure the temperature and how much temperature we will be able to draw away from a component like that. So that's the progress that's going on. It's not yet completely clear how they will be mounted, whether we will mount them in between like that, so that they have two surfaces that can lead away the temperature. That also depends a little bit on the issues with high tension, where we tend to have sparks in unhappy places, and of course that would ruin the whole thing. It's more Earth phenomena, an atmospheric phenomena, because if you go into out of outer space, let's say out of the atmosphere into vacuum, the sparks will not fly. It will isolate much better than the atmosphere, but that's a different issue. So that's what we're going to do over the next period of time. We now have our new bots, and they're now in pure aluminium. Thank you very much for listening.